for a second. Can you see my screen?
I can.
Okay. Awesome. Yeah, just some questions that were coming up here on our Slack channel, and let's see here. That's Philip learning about the generators. Where's the question? Where's the questions? Here we go. Oh, here we go. We're up here. Philip found his gold mines. Right. Object dot assign. Where's our Cobol guy here? There's a code. There's that. There we go. Here is a state. Speaking of shared state, Quovo's token API allows only one token per use at a time. So within our API, it's a service that is used. I don't even have to say API. That's an implementation detail. There's this Quovo service, and basically, when you kind of post to it, we're getting back these responses from multiple. And the question is, how do multiple instances of the app know what the Quovo token is? Seems like we need shared state, i.e. a data service. And my response, and what I'd like to be clear of is, like we always say, Tom, I do have strong opinions. We all do. Myself does. I do. Philip, Brian, even you. But, weekly hell, that's the cool part about it, because, I'm always open to new things.
Sure.
But sometimes people who are around strong opinions, they they assume people won't, kind of bend their opinions. Not that anyone here has done that, just speaking from previous experiences. So, easy answer, Brian. The Quovo token is a side effect, meaning it should be injected into each app on a request. How it's done is up to the author. Had the same problem with DynamoDB, because I remember I was playing around with DynamoDB and had a similar thing when I was trying to fire off a bunch of different things, and then realized I was just like I was building something that didn't need to even be built. Does that make sense?
Yeah.
I was like first learning about it. I was hacking on it on the side one late night. Aren't we supposed to have a data bus? And I wrote the data bus is and should be HTTP, stateless, and the app instance.
SQS is kind of or SNS is kind of a bus.
Right. And the app instance needs to be able to fetch the token from a data source in case it starts up after the post. That not a solution for a private token behind a firewall being shared state across multiple processes. And I wrote succinct, immutable operations that require no state of the outside world. I mean, that's really where it begins in my idea. And then how do two processes share the token?
Especially if they're on two different machines.
Correct. Some other questions are we using SNS SQS right now, which means that possibly you and Brian might be able to jump on a call and share some ideas. And
well, I think, okay, so if I understand it, whatever this service is, you log into it and it gives you a token.
Correct.
And there's only one active token at a time per user.
Correct.
Yeah. So I would think I would think more than SQS for that. To me, the thing that would make the most sense there would be something like Redis.
I see. So we mentioned that actually.
Yeah. So somebody logs in, sticks it in there. Everybody checks it, see if there's a current one in there. Have it time out, every 5 minutes or something. And if they don't have it, like lock it and store it. I mean, it's kind of a pain in the ass, right?
Yes. Yeah. That's it creates code complexity for sure, but what are you going to do?
Yeah. I mean, you got to satisfy them. So yeah, I would think Redis would be a really good use for something like that.
Oh, right. what I do like about it, to your point, of course, Redis can still store to disk, but I try to use Redis as ephemeral storage,
Sure.
or correction, not ephemeral, volatile storage, or volatile storage of volatile things, and that's exactly what a session state I would assume would be within a system like that. So that's not too shabby, I would say. So then that means that Brian's question right here is valid.
Yeah, you could certainly do that.
Because I consider Redis a database. I'm learning to not even use this word so much anymore. I'm more so using the term persistence.
What did he say here? I mentioned. Could you scroll that down a little bit?
Oh, okay.
What is it there?
Where is it?
Right, it was the IC concurrency issues.
Yeah, no kidding. I just increased the size of this, so let me stretch this out a little bit. We're at the right spot though, and Slack tends to be laggy a little bit on me, so I made it larger. That means it went up. Here's the question.
Because when you're processing 3 billion jobs all at once, that's a little optimistic.
Yeah. Oh, yeah. Just throwing something out there, and that's optimistic.
Right. So stop moving.
What I was saying is that.
Okay, stop scrolling, please.
Okay. To your point, you said, you have to build it in that it may be called more than once. So I was thinking if you have just some exorbitant amount, not saying we would ever have 3 billion jobs, but I'm saying if you have 3 billion jobs, and you have a couple of hiccups, your system you shouldn't be programming around that one or two hiccup. You should be able to have that operation be called 3 billion times and the same response is going to come back. Isn't that the basis of idempotency?
Well, posts aren't idempotent.
Exactly. And that's what I actually mentioned too as well with the post and the put.
And whose post are we talking about? To Quovo or whatever their name is?
Yes.
Well, but it's not. It's a post, right?
Correct. We could go up and figure out what it is.
Every time you log in, you get a new token, and the old one gets.
Look.
Yeah. Right. So, okay, please stop moving the screen, please. Okay. So when you post that, it's not idempotent, period.
Yes.
So there you go. And so they're not doing anything wrong. Right? Like Quovo's, allowed to do whatever they want on a post, and it doesn't need to be idempotent. So that's just that. So when somebody gets this, when you need a token, you need to go get one. You need to prevent other people from getting them at the same time, therefore invalidating the one you get. You need to store it in the database. You need to store it somewhere, and everybody else needs to check that place first. Right?
Right.
Yeah, and Redis is effectively an app global, right?
Right. Now let's think about this, though, Tom. The way that I'm learning to build systems is think Redis. So say it was needed that someone authored a feature where it's like when the token's created, it's stored into Redis. Then the cache is invalidated, if you will, if a person gets a new token or signs out. So that in quote unquote invalidation of the cache, typically people will go and do an update delete or find and delete on the record. And I'm learning to build the revisioning systems. So just that means always being additive. We've discussed this many times before too. So how would one really build a system, say even in Redis, because that's just an implementation detail, where you're not deleting anything and you're always being additive? I'm assuming something would go along with the timestamp or.
So the biggest problem here is you can build your system that way, but Quovo hasn't.
Sure.
So every time you post, there's a side effect of the old one being deleted.
Okay, I can dig that. I can dig that. So
Like that's what they're doing to you.
so then you can build it that way. You would just build a system that would just basically on insertion would have some sort of timestamp on it, and then you just make sure that it's indexed with newest to the oldest. And as long as you go limit to one, then that's your key or your token.
Why do you need to? I don't understand why you need to keep the old ones.
I'm just using this as a for instance of building version systems. I mean, if this was in PostgreSQL and it was an accounting system, it would make total sense, right?
Yeah, I get that.
It's just a pattern. I'm talking.
I mean, so in a way you could do it. A way you could do it in Redis, if you need like a certain amount of historical data, is, they have like queues, and you could say, you could push it on one side and trim one off the other end if the length is greater than a certain length.
Right.
Like
Which I prefer that architecture.
It'd be easy to, well, I would prefer that architecture if the other ones were useful in any way. But the problem is Quovo instantly invalidates the old ones.
Well, the other ones are useful, and I'll tell you why. Because then the information it does provide is the session token is the token itself is superfluous. The transaction of the timestamp of when someone actually yanked a token out of Quovo is the value.
No, because timestamp. Newton says there's no such thing as a timestamp. You can't build any kind of concurrent systems on clocks. There's things called vector clocks that I don't really understand, and I understand almost everybody that uses them misuses them, and you don't want to try to build a vector clock system.
Yeah, for sure. But I mean, if I linked Tom to midnight on Christmas Day, like irrelevant of that, the token is just an attribute of those two things, but that's essentially my key. So it's not like the timestamp is the key itself. It's more like the business key is the timestamp associated with the actual, I don't know, user, if you will. Which I hate that word.
I know. Could you tell me what problem you're trying to solve? Or are you just talking about ways things could be done? Like, I don't.
Well, it's a mixture of both. The way that things could.
But let's talk about them one at a time.
Well, the problem we're trying to solve is that if every single transaction of something that happened within a system, if you kept everything, period.
Is that what you're trying to solve, or are you trying to make Quovo work?
Well, I'm trying to make Quovo work, but I'm building systems that work, that are having a lowest common denominator of this pattern. And it's started ever since I've been working with Bloomberg, when I realized that, disks are cheap and storing more information than you need is good as long as it's in sensible order.
Okay. All right. So I'm fine with that. So for some reason, you think it's important to store forever useless login tokens.
Well, see, that's the thing, is that you've juxtaposed.
Well, they can't be used again.
The tokens can't be used again. You're absolutely right. But if I wanted to know how many tokens someone's had to have gotten over the past year via Quovo, I'd be able. What do you say?
Someone.
Well, if I had to know how many tokens and when tokens came, every single token within the past year of us using Quovo, if we wanted to say if they charged us per token, maybe that's a question you ask, Tom. Do you get charged per token?
Well, I would suspect when I ask, why do you want to keep them all, you'd say why.
Right. Yeah, totally understandable. But even if I wanted to get charged per token, that'd be a valid reason of that architecture.
Yeah, that would be a perfectly valid reason.
And I don't care about the token in that case, too, by the way.
You better be able, if it's gonna come down to a billing dispute, you better have the tokens.
I see what you're saying.
Otherwise it's just, well, I think I made 500 and you say I made 1,000. It's like, dude, I got a list of all the ones I made.
I see what you're saying.
Who's got better proof at that point, right? And even then, you're solving an adversarial problem that doesn't even exist in advance. Like, but okay, so you want to store all the tokens, right?
Yeah.
If you want to do that, then Redis isn't the answer,
Okay.
because like I just don't think it's a great place to store massive amounts of data. Like it's fundamentally its fundamental use case is, you know, stuff that can be rebuilt should it need to be. I think if you use Redis for anything else, you're doing it wrong.
Absolutely. So the way that you construct that system is that so what is it in versioning database architecture? You have everything would have a timestamp. The view would actually be by indexing. Is it descending when it's newest to oldest? I always get them mixed up.
Ascending is higher on top.
So that higher
No,
is
no,
new.
I'm sorry. Ascending is higher on the bottom, so 1 to 100 down.
We're talking about in dates. Because that's where my confusion goes. I get that.
You want those to be stored descending.
Got it. So descending means
Most recent on top.
precisely. So the way that I pull the system off is that say you start from every single one, say they're all stored in like Postgres or something like that. To say Redis kills over, and I guess before it dies, hopefully there's some, I don't know, event you can hook up to, I'm sure, that it stores all of the data, or you do some operation. Just dump all of those into some database that becomes your warehouse, if you will. And if you ever had to bring up an entire Redis system again, and you just do the view on that token list, descending order, limit 1 if you wanted to just get 1 per client or something.
Right, but if you're going to persist them in the database, then they should be persisted in the database. Like you don't need to persist them in 2 places.
I see.
Right? Like there's no reason to have them in both. Now you might insert Redis between
exactly
the data store as a cache.
Right, because what you do is you dump it into cache. You dump it into cache first before it actually even finishes writing to the disk. That's the whole thing they were talking about, that architecture. If you use HTTP, make a response into it, and get a response back out as fast as possible, and all that endpoint is just firing off a message to start up some queue. It really is sexy when you can assume what the person or what the client is going to ask for next, because then you can front load a cache in that regard.
Right. But the cache should be loaded after you're down on the database, because if it doesn't make it to the database, you don't want it in the cache.
Right. Well, then that's easy. This is from the HTTP2 spec, is that you throw it in the cache and then you perform some operation. If it winds up triggering some message to say that operation failed, then you just remove it from the cache, and both of those systems are totally independent of one another.
Yeah, you could do it that way. But then you've got races. If one happens before the others, that's pretty dangerous.
Right. Well, that's just what people are saying what to do with HTTP2. I don't know that much.
I think it makes more sense to not put it in the cache until it's on data, because if it's not in the cache, then you just get a not found when you try to read it. Like you don't make any promises that the system is consistent. It's EC, and it just works great most of the time. But it'd be a big problem if you put it in the cache, it didn't ever make it in the database, you return a 200, they hit it again, you have it, and then tomorrow it's gone.
Right. There's got to be some sort of there is a HTTP status code that's I think it's in the 200s, or it's definitely in the truthy side, and it lets you know that the entity you're seeing an entity, but it may not be the most recent version of what's going on, which I think is a very interesting code. Because like say accounts, and remember we were trying to figure out like how to really cache balances and all of that stuff. Say it's subledger, if you will. This is, we're talking unicorn land here, but say in subledger, if you will, like you have a posted transaction. You would assume that a client, I don't want to say person, would want to be able to read an account balance. So say an account balance is 1, and you do a transaction that's going to add or going to place another 1 into the account, which makes it 2 then. Say it takes forever to process that one, maybe 5 minutes.
Yeah.
What it could say is that, okay, well, we knew that the account balance was 1 previous to this transaction. I'm going to go ahead and cash the account balance as 2 while that operation is going on. But that's going to be listed. If you go to get that account balance, it's going to be listed as whatever this is it, but might not be the most updated version. You might want to call back when we can put a padlock on it to say, yes, this thing is officially what the balance is.
Does that exist?
Yeah, that exists.
What's it called?
HTTP. Though that's in the HTTP 2, some of the HTTP 2 usage specs. But I think that's
2.
Yeah, but I think that you can just build the system that way, Tom. Like, you don't need HTTP to do that. It's pretty
well if you want to signal it.
Correct. Exactly. Absolutely.
HTTP 1. I don't. Okay, created, accepted, non-authoritative.
Yes. Which code is that?
203.
Yes, that's the one.
But is gathered from a local or third-party copy. Yeah.
Yeah, that still satisfies that.
Yeah, that's pretty interesting, actually. If you get it out of the cache, you return a 203. But that still isn't the same. You don't want to. Here's the thing. I think you do have to have that be. Well, let's put it this way. Except for performance reasons, there's no reason, I think, to load the cache asynchronously.
Correct. Yes, you're absolutely right about that. But now, they're
like the reason to load the cache right away is so that if they call back again right after you give them a 200 and it hasn't made it into the database, you can return something that's good.
Right, because I mean, this is more of trailblazing along the how fast is really fast and responding to the client.
Right. Correct.
And starting in that direction.
Well, what I think is even more important is providing kind of non-surprising semantics. So you return a 202 processing on like a put operation, right? And then if they read it back again right away, it sucks if they don't get what they just put in. Now, 202 says, that's perfectly valid behavior if you throw them a 202, but it's awfully nice if you don't confuse the shit out of them by doing it.
Right. Well, that's, of course, why your brain's confused is because you said if they get something that they put there, and if you would never, ever return you'd never return a 203 from putting something. Heck no.
No, it'd be from getting.
Yes, correct.
No, what I said is you return a 202 processing. Scroll up a little bit.
Right, that would be from a post, of course.
Or a put.
Yeah, I guess you could say that.
You could throw.
Okay, yeah, I can see
that. Throw it into an async processing queue.
Got it. Okay.
It's gonna get down on disk, and then you return a 202, and then they hit you again. It's perfectly valid to give them a 404.
Yeah, or even a 203.
It's even better if you send them a 203.
Correct, much better, and I'll tell you why. Because if I put something and I got a response back, like it's kind of awkward if I get something and nothing's there.
Exactly. So, but what's even more awkward is you put something in, you get back a 200-ish, and then in the future, it's not there. So I think the best arrangement is on those kinds of operations where you're going to do that cache, you put it in the queue, at which point you know it's going to get done. Then you put it in the cache. Then you return the success.
Precisely. And if it doesn't get done, then there needs to be a cache buster happen then.
No, because it's going to get done because it's in the queue.
Okay, I got you.
Like
if anything, it'll get done twice, but it won't not get done.
Right.
Got it.
Right. And and after you put it in the queue, but before it gets in the cache, like you have a 500 error, something totally blows up or the server just snaps off. At that point, they don't know what the hell happened. They can redo it again, and it's no big deal because it's a put.
Precisely.
Right.
I like it.
Now, where were we?
Well, where we were was in our Pomodoro we came to the consensus that Brian was absolutely right. That's definitely a great place to solve that problem. And once we solved that problem in 5 minutes, and then ever since then we've been getting to the meat of things and saying, okay, well, how do we push this baby forward? How do we crank this baby into a 7th gear? That's what we've been doing. That's where we are.
Yeah, well, I mean, that's a general. I mean, that's the last slide is all about that, right?
Uh-huh.
On the Rio mode.
Right. Let's see here. We'll go look at that slide. Why not?
You've got it in French.
Past meetups. There we go. There we go, right here. Oh, nice. You made a comment in that for me. That's pretty cool because I was in the presentation and I just threw it up in the link because my Thunderbolt wasn't working. So you're saying it's the last slide. Let's see here. All right.
Right. So what we just talked about is, let me bring that up on my side.
Okay.
So on the bottom row, we've got patch put, delete, blah, blah, blah.
Yeah.
It would look like this.
Why don't you share your screen, Tom? If you don't mind, sir.
Sure. What? Who I did that with? Oh, that's you. Okay.
Huh?
Oh, you want me to do it in?
Yeah, if you can, if you don't mind.
In this thing. Share screen.
Excellent.
All right. So that would look something like this. Like this is more of an arrow thing or something. Like I don't want to make the space, but cue it here. Right, so it goes in pub sub, then it goes in the queue. Actually, probably up here is better, where this guy can get it, cache retriever.
Right.
Sorry.
So that cache retriever, that's exactly the layer we're just discussing just now, right?
Yes.
Got it.
But it's loaded from this line, right? It goes into pub sub and goes in the cache. And then the get line checks it. Like, can we get it out of here? If so, do it. Otherwise, go all the way to the data store.
Got it.
Does that make sense?
Makes total sense.
Because this can happen in like under a millisecond. We can be in the cache in, very short amount of time here. Into the queue and into the cache. The queue is going to take a while to get all the way to the data store. Right?
Uh-huh.
Like it could take quite a while if you happen to be backed up on the queue for whatever reason. The back end servers could be shut off and you could just be queuing them up in the queue, right?
Right.
So it could take a minute to get to the data store, but you'd still return them out of the cache just fine.
Okay, I can get that.
Yeah.
Sweet. So that's pretty good, Tom. That just actually wrapped up. That's my Pomodoro dinger right there. So it's asking, how do we feel about it? Do we feel happy, great, or incredible? 1 or 2 or 3 stars? Well, I guess that's from answering what did we learn. We have to. I should have asked that question first.
I learned that I have it's very interesting. Like I find it somewhat maddening and frustrating, but in some ways it's almost, like I can't tell if it's like a teaching style of yours or a communication deficiency. But like you had some questions about Brian and then you just morphed with like with no obvious change. It's like, okay, I got that. Now how would you do this? Like it seemed like one conversation. I couldn't tell what you were talking about.
Okay.
And I've noticed that in the past. Like it's very difficult to know like what you're talking about at times. Like when you switch subjects, you don't signal it.
Right. You're absolutely right about that.
Yeah. And I'm like, what? Like, wait a minute. Like, why are we talking about this? Like, so, and I don't mind switching subjects. It's just helpful to know that we're switching subjects. Right?
Uh-huh.
Yeah. So I guess this would look like something like this. At the end of the day, it's.
Oh, so that's a astute observation. But what did you learn?
I don't know. I guess I just learned that I've wondered whether you do that at times, and I think I just learned that you do for sure.
Ah, okay, got it. That's a good learning right there. It's good that you learn things like that too, because then you actually then know what to expect, or how to handle communication with people, because everybody does it differently.
Yeah, well, it's like, oh, Rashawn's doing his thing again. Right.
Absolutely.
I know what happened.
When I was real little, the doctors used to try to say that my brain was all fucked up.
Really?
Yeah, man.
What does that mean?
I don't know. They were just trying to say that I was doctors, teachers, all of that. And then my mom was just like, well, before you label him as something's wrong with the guy, why don't you try to challenge him a little bit?
What were you doing that made him think that?
I have to ask my mother that, actually. She just said that they would always say that I was just like bouncing off the walls, like mentally and physically.
Interesting.
And then I learned,
I guess what I just described is kind of bouncing off the wall mentally, right?
Yeah, absolutely. And then I learned how to program. And I always said to myself, one of the reasons why I enjoy programming and women, or computers and women, is because no matter how much you attempt to study them all, you can't know everything. And there's a vast amount of studies, a wide array of topics too, as well, that you can cover.
So Brian said, Brian had a note about the time through SQS.
Yes.
And first of all, I think he said 2008.
Yes, correct.
Like, Jesus, talk about, like not updating your thinking. I mean, one, it's possible that what he said is 100% valid. But I tried an Amazon service 7 years ago and learned something about it. And what's even the point of saying that? Like 7 fucking years ago. Are you with me?
Yes. Well, because I know the point of saying it, because I actually asked him, when was the last time that he built a SQS or SNS service? And I know that he started writing, and I believe he was just thinking about what was the last system that he built. So that's why I brought it up.
Gotcha. And then the question is what are the limits of interactive? What does he mean by that?
Okay, that's a great question to ask. I'm sure that I'll be able to get that answer from. That's the whole point of why I'm speaking with you about this.
I actually, and I'm not being defensive about it. I mean, it may well be. Like, I believe I've measured the traversal time through SQS, and there's a couple of, it has a couple of interesting properties. One is it's a distributed system. If you have a bunch of crap in the queue, it works kind of very consistently. Like if there's a whole boatload of messages to pull out and you say, hey, give me 10, you'll get 10 every time, right? But when you get down, if there's 20 messages in it and you ask for 10, you might only get 6. Because like the server you're connected to at the moment, there's only 20, it's distributed. Like not every server has 10 messages.
Right.
Right. So you might get a subset back. And I think the timing also goes up. Like, the time, like if you connect to it and say, give me something, you may have to wait for it to find a message to send you or something like that. So I don't, it's interesting. Like what does the system need to be used for? Right. And what does interactive mean? Because for most people, if you like, let me, can you see this screen? Can you see this screen here?
Yes, sir.
Okay. So if I typed a message in the iMessage here, I'm going to do it.
Just got it immediately. Like by the time your sound finished.
Oh, wait a minute. What was the second noise?
That was on my cell phone.
Okay. Which one was interactive?
They both were, because one of them I saw a visual display come up where you sent and your message, and the other one, my phone is about 2 or 3 feet away from me, and I heard the message go off that's specific for iMessage.
Yeah, exactly. But it was like 1 or 2 or 3 seconds later.
Precisely.
So the question is, what's Brian's definition of interactive? I think 3 seconds he would say isn't.
I see.
But the first on your screen, it was like instantaneous.
Yep.
So like that's more, his statement that it was unacceptable for interactivity. One is 7 years out of date. It might be totally valid. Maybe nothing's changed. But also the question is 3 second interactive? And I'm not suggesting iMessage uses SQS, by the way. I'm just saying, like, these things are kind of slippery subjects.
Yeah.
I know there's some traditional lore that I think is pretty accurate where there was early on in computing, especially personal computing, but I'm sure the same thing was true on like mainframes beforehand. There were questions about how much lag time is acceptable between like pressing a key and seeing it on screen.
Right.
And that was a particularly big subject when sometimes, hundreds of meters or maybe hundreds of miles of wire were between the keyboard and the computer and then back to the screen, which was by the keyboard. Right. And maybe over a 300 baud modem and shit like that.
Oh, I see. I see what you're saying.
Right. I mean, like communications used to be slow, and there used to be like a company in 1950, like, there were 8 computers in the US or something. Right. So not everybody's desk had a computer on it. And when they pressed a key, it had to go maybe a long fucking way to headquarters and back. And the general belief was at 30 milliseconds, to the human mind, it's basically the speed of light. It's like a light switch. You turn it on and the light's on instantly. Okay. That feeling happens at about 30 milliseconds and under.
I see.
Okay. Like if it's under 30 milliseconds, it appears instantaneous to people. If it gets over that, that's when it starts feeling laggy. like you type and it's like, well, where's the fucking letter? There it is. Right. And the longer you get, the less interactive it is. So the question is what were they trying to build? How was SQS back then versus today? Like, I know those fuckers at Amazon, they've made SQS better and better and better. That said, SQS is totally designed to be reliable, high volume auto scaling. I don't believe it was ever intended to be a low latency message bus. Right. So, you know, there are things that you can run like XMPP and AMQP. There are other things that pride themselves on latency of message delivery. That, and you know, I don't think it's any big surprise that SQS isn't. That's not what it chooses to. That's not the problem it attacks.
Right.
Low latency.
Right. I see.
The and then what I don't know, but it might be a fun experiment to run now or some other time, is to hook SNS to SQS, pump a message in, and see how long it takes to come out.
Right. Just like a simple function that does nothing, right? Well, not even that, a message.
Well, just a loop back. But the thing is, I've played with SQS. I've never played with SNS and SQS together.
Got it.
Would you like to do that?
Yeah. ASAP.
Now?
Can it be ASAP within the next day? Or actually, sure, why not? Let's do it now.
Okay, so let me get a file open. Save. Require. I think that's how you do it. And Ruby RVM shell. Really? What the fuck's the name of it? Isn't that what I typed in?
Pardon?
Oh, AWK. Okay. Ruby SDK. SNS. Client.
I can't see anything.
Why not?
I don't know. You're not screen sharing.
Really?
Yeah. Did I miss a whole bunch of important stuff?
No.
Oh, okay. I cancel that. There you go. Looks like it's okay. There we go.
And okay, SNS client.
Can you could you kind of give a statement or so? As I'm seeing you copy pasta, but I kind of don't know what's the thought that's in your head.
Sorry. So make a client, make a SNS client, right? And then this is the ARN is usually the way you access stuff later. Like we can probably get messages using this ARN. Amazon resource.
And what is ARN?
Amazon resource something or other. It's a vaguely URL-ish thing that is a unique ID in their system. An ARN is
an ARN. I see. The nomenclature is synonymous to earn, which is synonymous to URI, URL.
Yeah.
Got it. It's probably something resource related that's internal to Amazon. Right. Amazon Resource Network. Okay. I totally get what you're doing. You're just trying to identify different resources across your network.
Yeah. They use it for, I mean, it identifies the thing independent of the name usually. All right. So then we're going to need to create queue. I suspect we might well need this. I don't know. And there's nothing on here about it. So then SNS. So now we've got an SNS topic, right? Which is something we can post to and lots of people can subscribe. And now there must be a subscribe. Prepares to subscribe an endpoint by sending the endpoint a confirmation message. By sending the endpoint. This is a little more involved than I thought, to be honest. I wonder if we can find somebody else who does this. SNS, SQS. No. .NET. Oh, .NET. Fuck that. Okay.
So much shade, and it's nighttime, Tom.
Sorry?
I said so much shade, and it's nighttime.
Shade?
Yeah, you threw shade on .NET. Shade is slang for when you throw a jab at somebody on the sly.
I see. That wasn't much on the sly.
So that's extra shade, man. Like it's 12 noon underneath a fig tree. Oh no! What just happened? That can't happen. No way.
Oh, this is interesting. SNS client subscribe queue. Maybe it is easy. Wrong language, but well, we can live with that, I think.
Yeah, I was just talking about that the other day. You know, when it's good code, you actually can take paradigms from, because then they're just paradigms, right? You just translate the syntax.
Yeah. So.
I learned that really with iOS development when in my Swift development when I don't write Objective C, but I totally get it how like looking at this construct and the paradigm in Objective C and translating it over to Swift.
Oh, there we go. Topic ARN is this. Protocol is SQS. Yeah. ARN. So SQS. I absolutely detest when websites grab control of the keyboard in a way that basic browser functions don't work. Like if I command click, it'll open another window, but when I command click over here, it doesn't. That freaks me out, man. So frustrating.
Because Tom, you tend to forget the wheel can always be rounder. just keep changing and making it another wheel. Do something else. I'm totally being sarcastic too, because usually like that means like when people take something that just works, right, and they just keep trying to like engineer it even more. Like let's put our own thing into it. Sometimes it works out good, you know. Like look at Microsoft with XML HTTP requests. Without that, we wouldn't have Ajax. That was like a permutation of HTTP. But this is a bad version of it. It's like, really?
Where's the fucking ARN? So I've got a Q URL, but that's not an ARN. How the fuck do I get Q? ARN. I have an extremely hard time believing it doesn't actually give me what I need here.
like a super hard time believing that. Okay, and what is an endpoint? Okay, so that should clean up after itself. All I really need is the Q arn.
So by cleaning up after itself, are you stating that if you ran it, they wouldn't be idempotent? So what I mean by that is if you ran it 1,000 times, you'd have like 1,000 different permutations to the data store. Like if you really wanted,
it's gonna create them and then delete them.
right? And if you didn't have them, no, they would never get deleted, right? Didn't have the when you said it's gonna clean up after itself.
So I don't believe these creates are idempotent.
Correct.
I could be wrong. I don't know. I'm just going to be careful rather than leave a bunch of crap behind that I have to clean up manually. Okay, so we're almost there now. We're really close. SQS. SQS. So where is that? It was get attributes or something like that, which obviously ought to come back. Oh. I guess we'll just do it. Please tell me what can come back. QRN. Probably QRN. Okay. SQS client, why would it need that? That's a weird thing. So we wait 5 seconds in between here. I've been wanting to do this for years, probably literally like 2 years. I don't think we need any of this bullshit. Data type required. Oh, if the whole message attributes isn't. Message structure not required. Subject. Don't know what that is. Interesting though. Topic ARN, target ARN. What is that? Target ARN. Weird. Oh, if you only want to send it to one subscriber, maybe, or something. Okay, topic ARN, same. Strange. I suspect that's like in everybody. And the message is okay. Then finally, Ready to go? Okay, new SNS. New queue. This line is way too fucking long. So all of these really. I like this format. I didn't like it at first, and now I'm getting used to it, and I like it a lot more. You there, Sean?
Yeah, it's great for configurations.
Well, just anytime, it's great when you have really long fucking descriptive variable names. Okay, that looks pretty straightforward, man. I like that. Change mode 755. SRD. Oh, right. I need some creds. Keychain's great for storing credentials. Oh.
You're using my favorite testing framework there, Tom.
I know.
Put S.
Larry Wall said it was his favorite. What's his favorite debugging? He said print.
They'll never go into a pull request as long as I keep my fingers crossed. I've let one or three slip in there.
That can happen. Just delete you. Three shipped.
Pardon?
Ruby 2 shipped.
It cut out right when you just said whatever you just said.
Ruby 2.3 shipped.
Oh, when today?
Recently. We've been waiting for it for a while because it's supposed to fix some memory leaking issues.
Nice. Let's have support for Rubinius, please. Fingers crossed.
What does what have?
Ruby 2.3.0.
Does Rubinius have support for it?
Yes.
Probably not. Probably not.
Got it.
Rubinius guys they've started knocking out releases pretty fast. I think they're kind of going to an interesting place. I think they've been kind of mired in back some stuff that the original leader kind of left behind, but Brian's really been putting out very regular work and very regular releases and kind of putting stuff in. Seems to be a pretty nice space. All right. So QArn. Oh, we're not getting any QURL SQS test. It looks like these are probably idempotent, which is great, unless these come back with a different number each time. No, it looks like they are. That's very cool. Now, how come we're not getting anything back in here? It's the third request. 1, 2. Get Q attributes. Oh, because I know why. Because I didn't tell it what attribute I want. I thought it would send them all. You know, very specific, like only 6 things, but you got to ask for the one you want. AWS. It's not in the, yeah. SQS. Client. Get attributes. Oh, all. Why don't I see? Oh, attribute names. All. That should be the default. Attribute names. That's still no QArn. Okay, attributes. Oh, it's like that. Is that thing elsewhere? No. No member QArn, really? Oh, it's attributes. Got it.
Are you sure it's using homogeneous cheat or heterogeneous keys like that?
It just worked.
It did?
Yeah.
Oh, that's interesting. Usually I don't see too many hashes that have heterogeneous keys like that. Oh, attributes.
What they do is the top level can be, the top level is all keys, but underneath is just the raw data structure.
Right, which is always going to be in that format. Or should be, rather.
Really? Do I have to require it or something? Yes, probably. So yep. Oops.
Is the paint dry yet?
So it's either not working or it's incredibly slow. I can't possibly be that slow. SNS subscribe topic is oh, did it come back now? So we got a subscription ARN. We sent a message. That's here. Now we're polling for a response. Huh. Sign out. Okay, so here's this. And we've got an SQS. We've got SQS. Is this the ARN? 870-948? 870-948? Huh. Oh. Oh. fuck does confirm subscription mean? Okay, how about the code? Where are you? Love undo. Subscribe, sleep, publish, get it. Huh. I don't see anything about confirmation.
Well, why do you need a confirmation?
I don't know.
I
But
don't.
that's an option here.
Oh, I see. Yeah, I try to steer away from that.
Why?
Oh, because I'd rather just assume that the system works.
Well, I think I am.
Right. Yeah. So what I'm saying is that checking, I don't know, active record has a save method on it, and people check that to see if it's true, if the record was actually saved. That's like a confirmation coming back.
No, I don't think so. I think it's more like the ability to do like a 3-point confirmation. Like somebody wants to subscribe, okay, let them.
I see.
I think that might be it, but it doesn't appear to be necessary. I don't know what this is.
So we did get a message into SNS and the queue.
No, there's nothing in here.
Oh, I see.
Yeah, there's nothing in here. Permissions. Yeah, that's fine. It's not redriving.
What's redriving?
Redrive allows you, if a message is pulled off but is not deleted or refreshed before it times out, all of which is configurable, the timeout period, then it will re-deliver it. And redrive allows you to say, okay, try it 10 times. And after, if you get 10 failures, then move it into another queue. So it prevents infinite loops.
I see.
It's definitely, it's kind of, I don't think it makes any sense whatsoever to set up an SQS queue without a looper. We call them the looper queue. So it's like if you name Bob, then you have Bob loopers, and always set it up because it's, you need to know if you're getting failures on delivery and shit, you know?
Right.
And not just like lose them or whatever.
Do you have a looper for the looper, or that's you're pretty covered?
No, because nothing pulls out of the loopers.
Got it.
But we have a, oh, look at this.
What's that?
Where did that come from? Oh, that's something else. What that means. That was off initially. Huh. Well, I don't know. Huh. Oh, what is this? No, they're not coming through. And I have no idea why. Oh. What?
Isn't us deleting the queue the reason why we're not there?
Sorry?
Like we're deleting the queue. Isn't that the reason why there's nothing in the queue?
I don't think so. Like I think we're hung up in this loop here.
Okay.
Yeah, we can't really see what's happening inside of here, but I think we'll see we hang up here. Sleep 5. Hmm. Um, hmm. Give SQS send message permission. Before you subscribe a queue to a topic, you need a topic and a queue. Yeah, we got that. Create a topic. Set a policy. It's the Amazon SQS or the set queue attributes API action. I would love to do that. Set queue attributes. Let's do it this way. SQS permissions There we go. Allow. Select allow, select everybody. And then send message. Add a condition that allows the action for the topic. Click add conditions, select ARN equals. Okay, this is going to make it much easier. Click add conditions. Select ARN equals. AWS source. Source ARN. And then we need go, go, go. Boom, done. Yes. Sweet. Delete SQS. How is this not the same as this? SNS, delete topic response. No 2H. Really? All of the rest of them have 2H and this one doesn't? Is this like a bad joke or something? Weird. Okay, so that worked, dude. So I'm going to set a time here. Doesn't matter.
That worked, man. Wait for it.
It was faster last time.
Wait for it.
Oh, I know what the problem is. The problem is we deleted it and recreated it. Which we don't need to do. So let's comment this bullshit out for now. And let's reset that permission. I gotta get that in the code. Allow everyone. Send message. Add conditions. Aren't equals. So 0.8 seconds.
So what does that mean?
It's 800 milliseconds, right? From SQS to, from SNS to SQS, out of SQS. So it's pretty fast. It's sub-second, but it's not 30 milliseconds, right?
What do you mean by it's not 30 milliseconds?
Well, 30 milliseconds is that time I told you where it's considered instantaneous for human response times.
Right. So whatever would fire off this operation, I would assume to have long responded before probably even this operation got started. So like say like an HTTP request that you post off somewhere to create something or it would be the post spec states that the API you're to assume that it can communicate with external systems, and there will be side effects.
No, what I was testing, I don't have a problem with 800 milliseconds, though it would, like using this in Subledger would increase the latency of posting operations, right, which I would be willing to put up with, I think, for better architecture. But I'm just saying what it is. I think it'll work better in regular operation. This is probably about as long as it can get. Everything was just created. Probably never going to be worse than that. Let's see. Yeah, almost identical. Right, 808.
Can you run it a third time for good measure?
Sure. No, but the reason I just pointed it out, and the reason I wanted to try this was to have hard data on what the concept of his concern about interactive.
I see.
And it's like, this is the length of time this two-hop operation talks. And he said SQS wasn't acceptable. SQS would be faster yet. So I can also throw in here. Let's do this too.
I think Brian said what wasn't acceptable. I just think that I just want to understand how it can be.
No. He said in 2008, SQS wasn't acceptable for interactive operations.
I see.
And I'm just trying to qualify that, like it's 0.8 seconds, and this isn't just SQS. This is SNS to SQS.
Right.
So we can do SQS. What is that call? Let's throw two messages through. Lost my place. Huh. Oh, it's better actually. That includes the time to put it in, which I guess is reasonable, right?
Yeah, absolutely. I mean, that's 0.8 seconds for a side effect is.
No, but it's 0.8 from putting it into, like, to put it in SNS, have it delivered to SQS, and then be sucked out of SQS.
I see.
Like, it's the full round trip.
I see.
It's not 0.8 seconds inside the system. It's the whole time. So this would be a lower number if we were on an EC2 instance, a little bit, possibly considerable, because it's East Coast and back. Like probably 200 milliseconds of this is is there a URL in here I can hit? Yeah, you fuckers. Why do they do that?
Is that like one of those fake namespace URLs?
I don't think so. I think they just block ping requests for whatever reason.
Pings don't go across. Oh, they go across TCP, not HTTP, right?
Right.
Got it.
All right. So oh, we're not deleting the messages. Wait a minute, maybe we are. Seems like we got some of these again. Yeah. Okay, so look at this. This time, much faster. Cindy, directly through SQS, took 250 milliseconds. Through both took 465.
How much latency is that from not being within the Amazon ecosystem?
I don't know, but probably at least 60 milliseconds to the East Coast and back. No, that's not true. That's round trip latency, I think. I'm having, yeah, what can I hit on the East Coast that's going to take a ping? Like even the Dynamos, I don't know what's... Just ask. West Coast to East. Time to US East. Okay, server fault. How much network latency is typical for East Coast to West Coast?
Is that a question to me?
No. We're talking quite a bit here. Quite a fucking bit. Like 200 milliseconds West Coast to East Coast. God. Please give an over detailed response, please. Oh, nice. Where the fuck is this from? Nice. Okay, San Francisco to where are they?
Northern Virginia, probably Vienna, or something like that. Just do Washington D.C.
Oh, that's where is it? Is there DC on here somewhere?
Yeah, Washington. Oh, Seattle. I don't know if that's the Washington. I would say it is. Yeah, the last column is Washington. That's where the servers are near.
I don't get it. I'm a little lost here. Washington to Washington. How do you read this thing? Maybe San Francisco. SF to Washington, 71. SF to Seattle would be 16. St. Louis, 50. Yeah, that makes sense. So maybe 70 milliseconds of that. And we're making several requests to do that. So we're getting, here's what we're getting. So start time, here's 70. Okay. Then 70 to queue. And then we're done. So 140 of this time is probably on the network. So this is getting down to around 100 milliseconds, just raw SQS time. And SNS to SQS is something along the lines of what do we just say? 140, 320. So a third of a second.
Okay.
Right. That to me. That's certainly okay. A lot of API request times are like 300 milliseconds, right?
Correct.
So it's as fast as that.
Even go, okay, I got it. And that's without the round trip cross country.
And so it comes down to like this, right? I don't need this anymore. Like basically your client hits you, and by the time they get their message back, you've also hit the back end. Right? It's like it's 300 milliseconds from them to you and back. And it's 300 milliseconds from you to SNS to SQS. Right? So it's, and this isn't going to take long. So, you know, by the time they get the request, you're probably done as well.
You mean response?
By the time they get the response HTTP, you're probably on, you know, finished through the back end as well, unless they're in Dynamo as well. Now, you know, do you have access to A convenient server you can log into?
Define log into. I mean, I have a Heroku account in the AWS instance.
Yeah, an AWS instance.
Or yeah, well, sure. Hold on a second. I have to find the
Does it have
credentials.
Ruby installed on it?
No, I don't. It's not. I have an. Well, let me rephrase it. I have an account. There's no servers running. There's a node.
Yeah.
There's a node instance though.
Well, let's forget it.
Thank you.
Yeah, no problem. So anyway, that was pretty interesting, and I think, yeah, my take is I wish it were faster, but I can live with it. You know, I mean, faster is always better.
Yeah, this is under the assumption too that this is constant.
Oh, I think that's highly likely. Amazon's quality of service is quite good.
Got it.
Let's run this again and see what happens. There's as much of this probably has, and again, the more messages are flowing through, the more likely this is going to improve. Like, and particularly if you have several back ends listening, the chances are lower. Because again, it has SQS very clearly, and they state it in the docs. Like, if you connect to an SQS, if you connect to an SQS queue from one instance and send one message through, you'll get very different. You'll get very kind of erratic results because SQS is distributed and you're only connected to one server.
Exactly.
That's like the worst case for them.
Yeah, it's like writing code that runs on a single core on a processor.
Except it's a little different in that they have to go figure out where that message is actually held and still get it through. Like,
oh gosh,
I don't even know how it works. Honestly, it's
so that would be so it's almost like I just know, like, say for instance in Java or C#, whenever I start running things, it's like the more it ran, the faster that certain responses would get coming out of it, and I guess that would be like warming up the applications.
Yeah, it's not quite like that. It's like in ASCII terms, and all of these numbers are totally arbitrary, right? But you've got a connection to SQS, okay? And you think of it as like, this is your queue. But in reality, your queue is distributed over multiple machines. And when you send messages in, it could end up on any of them. And the more messages you send, the more machines they get involved. Like, they automatically horizontally scale SQS for you. You don't have to turn a knob or anything. You can send one message an hour or 1,000,000. They don't give a shit. Like, they claim like effectively infinite scalability. Okay. So the problem is if you connect to this server, but the one message is over here, you will get it over here, but this one has to go hunting for something to deliver.
Yeah.
Whereas if this one has a message, and this one has a message, and this one has a message, and you connect to it, you'll get the one it has instantly.
I see.
Right? It's like the queue's full, and it's just like, here you go, here you go, here you go. Right? So its behavior is like statistically erratic at low volumes. At higher volumes, it becomes just steady as hell.
That makes total sense.
Yeah. Yeah, I think that given the basic power of what we're talking about for implementing this kind of architecture, I think it's a dream.
Well, it is kind of late, so we probably might be right.
Dreaming? Oh, it's later for you. I forget.
Oh yeah, no worries at all. I wouldn't miss this for the world.
Cool.
So that so what else did we learn? The last Pomodoro, the one thing that I learned I didn't get to mention was kind of grok the 203 response code a little more, and how it can be used. And also I learned a bunch about SNS and SQS as well. What about you, Tom? What did you learn? And really, a question I have for you is earlier, towards the beginning of the second Pomodoro, you said, I've always been wanting to do this for so long, sounded like years even. Did you accomplish it, and what was it, quote unquote?
I, kind of investigated and poked around the corners of how SNS to SQS delivery works and some of its characteristics.
Nice.
Like it's not a mystery how it works. And like I knew you could do it. Now I know how to do it.
Right. Yeah, that's always empowering, right? That's a little seed. Because that wasn't too painful, actually, if you really think about it. I mean, I'm pretty sure you've been thinking about it longer than a couple of hours, and I mean, we got that done in a couple of hours. Really, we didn't get cranking on it till like an hour in. So,
SNS to SQS.RB. Yeah, I think I'm totally happy that we did it and whatnot.
Yeah, great. So cool. And I got the slides and some implementation now, right, Tom?
Exactly. Yes, yeah. If you need that code, the only thing that code needs is it really needs a it needs the permission thing handled. So you can just run it and it'll work without having to go into the console and fuck with it by hand.
Right.
Where's create SNS? No, it's on the queue actually. And that is here. What? Love that command. What? Why is that up there? How is it open, but I don't have a... Damn it. Copy. There we go. Sweet. Good night, fine sir.
You done?
I think so.
Awesome. Sweet.
Unless you have something else to talk about.
Nope, that's it, man. Yeah, well, actually, I do. I want to say, Tom, something that's definitely, I'd say, sort of personal to me, and such as that. I think maybe I always tend to think of my life has been a combination of different things. When you were talking about, what did they used to say about you when you were younger, and then oftentimes people always have to be realistic about like who they are physically and things like that.
Mm-hmm.
And I remember I always get brought back to. I'm like, well, damn, I played hockey I was captain of one of my hockey teams and also played ice hockey and roller hockey, football and lacrosse. I think I probably had about 7 concussions in my life or something like that.
Mhm.
Definitely a ton of mild ones and like 40 or so like dislocated shoulders. No bullshit too. It's funny because I was talking to one of my friends a couple of months ago, and they were like, you have to understand your the way your brain works. That's why you're in your field. It's like a gift and a curse at the same time, because your brain really kind of works like a machine or a computer. I start noticing sometimes my brain is thinking so much more faster than even words can come out of my mouth, and then it's like what I tell my mother. It's like what I say, my brain short circuits, because it's like my vocal cords or my tongue will like just spasm, and like I can't, it's like they're like frozen.
Mm.
And then I just have to like, breathe and calm down and then get into that. And they're just like, you have to also understand that, a lot of the ideas you have are, what she said, she was like, they're genius. There's this quote I like to say, the difference between genius and insanity is just how many people agree with you.
Right.
And she's like, you have the empathy for other people. Like you could see a lot of things in your head, and your head. Some people who are talking to me, I'm either looking someone directly in the eyes, because I consciously focus on that, because that's a big deal to me when you're communicating with someone, to look them in the eye. But then when I'm thinking. Like people even notice when they're talking to me, like they said they could see it in my eyes, like my brain's like all over the place, just like trying to calculate things and such. And I'll notice that because I'll be talking with someone and they'll look, and I'll see them looking like in the direction that I'm looking at. And I'm like, wow, I'm totally, throwing them off a little. So I have to be conscious of those things. But I do know that the people who are really close to me, they probably notice it the most. But I understand and I'm aware of it too as well, and they help me out with it too. So I thank you for comments like that, because it always makes me a better person to be more aware of like areas I could get better, and more realistic too. Because sometimes people beat themselves up and try to force themselves to be something that they're not, when they just sort of be humble, and other people usually around them are just like, hey dude, nobody's perfect.
I've kind of come to the conclusion, it's really interesting. Like there are some people there. I mean, I don't know if it's the same, we're experiencing the same thing or similar things or whatever, but there are some people I can explain shit to, and other people I just can't. Like, it's really weird. Like some people they're just like, what are you talking about? And it's like, fuck, dude, like I just said exactly what I'm talking about. Like, it's like I couldn't possibly have been more clear what I was talking about, right? And other people are like, oh yeah, gotcha, like totally clear.
Absolutely.
Yeah, so it is interesting, but like in that one thing, that we were chatting about was, did you send it through? I think you sent it through this way.
Yeah, definitely been talking messages to you today.
You're like, oh yeah, just need a response to that. Right? So, and the response is, back in 2008, I worked for Grocket, real-time collaboration. We benchmark SQS using raw event machine. Like that is going to affect anything, which served long poll HTTP requests from the client. SQS plus event machine was too slow for real-time experience back then. Like I don't, that's such a random statement, but it's clear that it wasn't acceptable to them, right? Although I wonder sometimes, like what engineers think is acceptable and what's really acceptable is sometimes just so fucking radically different, right?
True.
And what were they sending? Were they sending keystrokes? Because that would suck.
Yeah. It's that real time thing. Think about it. Like, when Tom sent me a message over iMessage, if I didn't have my computer open, then I'd say, oh, Tom just sent me a message. However, that would be 3 seconds later. That would be actually real time to me.
Well, again, so it depends on what we're talking about and what real time means. And what the tolerances are and what the biases are of the people who were making the decision and everything. So there's a whole bunch of shit involved in there. But we just saw, SQS is about 100 milliseconds, which is 3 times as long as instantaneous to the human brain, which means it's pretty damn fast.
Yes.
Like 3 times instantaneous is fast.
Yeah, and that's just a straight linear scale too. That's like a horizontal scale too, infinity. Because it doesn't matter how many you put through, the number's pretty much going to stay fairly constant.
Yeah, as long as you can serve the requests on the back. So, but what was interesting is, so, you said you wanted this, and then we started talking, and you didn't talk about this at all. And that's what was confusing to me. You were like, well, post and side effects and this other problem with the token. Like, that's what I meant, where I was like, wait, what are we talking about?
Right. Well, there's 2 different contexts. One of the reasons why is because there was a lot. I mean, we had a large pretty lengthy conversation in Slack. There were a lot of things that came up that were, some were, okay, here's the problem I'm having, that sort of spiraled out into these are the things that have sort of been on our mind or sparked in our mind, and we kind of flushed those out, because you always want to kind of get ideas out of the people who are around you, so you can sort the crap away from the free jewelry. And it's, that answer was more, which I should have stated, was over text message. You could have just sent that answer, because that was something that a colleague was stumbling over and just wanted to serve his need immediately. But then when you got on to a hangout or sent me a call, that really, there was a bunch more questions that were nice to have, but that one was really the must have. And I kind of understood exactly what it was. Like, afterwards he said maybe we should use Redis, and then when you confirmed that, I was just like, okay, well, whatever opinions are there, those are weakly held. We'll just use Redis. Questions, problem solved.
Yeah, I think it needs to look like this. So let's talk about that. So you need to get, because he was worried about the concurrency issues. Get token from Redis. Okay. Success done. For a 1 response. Lock token key, get new token, store in Redis.
Can't you unlock before storing in Redis?
What's that?
Can't the unlock operation happen before storage in Redis?
So, say it again.
Can the unlock operation, what would happen if you put that on 7.5?
7.5. Oh, here. No. That would be a disaster. And the reason is somebody else could race, get another token, and invalidate the one you're about to put in Redis.
Oh, so the lock is based off of Redis persistence, not the lock whatever is generating tokens.
Yeah. Redis has a really good semantics for locking.
Right. So this lock and unlock, you're talking down at the persistence.
Yeah. Get token
Okay.
from Redis, make request success, done. 401. Well, we don't really need to say that.
Can we put a space between 3 and 4? All right, cool. Awesome.
Attempt to lock, token in Redis. Not token, really. It's token. What's the name of the service?
Quovo, Quovo. Exactly. That's exactly what that thing is.
Fail. If you can't get the lock, no, not.
I see what you did there.
Get to unlock. Yeah, that's heinous, but somebody else can work out the fucking details. Quovo, yeah, that'll work. Why don't you take a copy of that?
All right.
I'll send it here. I was thinking we were screen harrowing.
Thank you, sir.
I think that ought to work.
Awesome.
Yeah, maybe. It's actually, this is really important. 0. Usually the locking clients will allow you to say, like, I'm willing to wait up to 30 seconds to get a lock. Wait time. If that thing's locked, fail, sleep 1, go to line 1 or something like that, Yeah, that ought to solve that.
Well.
Was that interactive?
I think that might be the first time I've seen you write a recursive function.
I don't, maybe.
Yeah, it's definitely recursive because the only property of recursion is that it's infinite except for one edge case. And it can only loop once.
Wait, didn't? Yeah, I mean, I've certainly written them before in my life.
Yeah, it just all starts with that go-to line 1. That's the recursion, dude.
Nice.
Well, that's great, man. That's a TLDR, right?
Yeah, pretty much. That ought to cover it. Cool.
Well, that's sweet, man. Gonna go. Give me 1 second here. I want to try something out. Oh, there's Tom's message.
Totally non-interactive.
Well, Oh, that's strange. Okay. Okay. Wow. Splendid. They're doing smashing. So, yeah, Bitcoin's doing well, man. 435. I hate juxtaposing it to monetary U.S. dollars, but
It's made a couple of rushes up over 450, and then it tends to back away from there. Like it's kind of interesting. Like I think there's a lot of disagreement in the world right now over. There's a huge disagreement between the actual authors, which now that's not, well, they're certainly the authors now, but let's call them the maintainers, because the original author is just gone, right?
Right.
So the maintainers are aggressively pushing back against the general desire in the community to make Bitcoin a general purpose payment system.
Yeah.
The reasoning being, which I initially disagreed with, I was like, and it's the right, this is a great example of where like both sides are right, but they can't, neither side can agree that the other side's a little right. Like they become polar opposed, and it's not helping Bitcoin. I don't think it's going to hurt it. It's delaying it, and it's confusing the subject right now. But so it's like this. So every transaction in Bitcoin gets stored on every full node at, which anybody can run, right? And if you want to verify your own transactions and know for a fact that you know what's going on in the Bitcoin network, like if you're a merchant, it makes a lot of sense, right?
So, Tom, guess what I did?
What'd you do?
I got us a couple coins.
Nice.
And I want to know, you see what I put down at the bottom?
Oh, rocking good. How do I get you what you need? Hold on. You gonna keep one?
Yeah.
Good for you, dude. I think that's really wise. Like that may be one of the most important decisions you ever made. Or it may be as retarded as playing the Powerball.
Oh man.
It'd be nice to, get $1.5 billion overnight, but it's way more likely that you're going to be struck by lightning in your lifetime.
Yeah, this is true. I'd say I think the odds are like 4 times in one day, if I'm not mistaken.
But somebody, the winner was in California. Like somebody in California made $1.5 billion tonight. That's going to be a life-changing fucking experience.
Yeah. The winner's in Cali, huh?
Yeah.
Wonder if they buy everybody. I wonder how many gallons of water you can buy for that and distribute them amongst the state.
It's raining. I think our drought's over, dude.
Yeah. I heard it was raining a bunch last week.
Yeah, I think we're going to be okay. And it's almost as important as the fact that it's raining is that every time it rains, it snows in the mountains and it's staying cold up there.
Yeah.
So we're building snow up in the mountain. Nice. Yeah.
Sweet. So nice. Got this guy here. Oh. Let's see here. We're going to send. Continue. Send to, paste, done. Why doesn't it let me press continue? Do I have to put a message in? Coin. Oh, I'll put in real mode. Real style. I'm learning myself, man. Done. Oh, you've got to be kidding me. Why can't I press why doesn't continue button work?
Are you sure you got, let me send you an address through again.
Yeah.
If it doesn't, if there's any problem with the address, like the addresses have checksums and shit on them.
Oh, okay. Let's see here. Maybe I copied a white space character.
Could be.
Yep, I copied a white space character. Nice. It was the white space character.
It ought to be able to strip white space, but it's nice if you ever, God forbid, you ever have to type one by hand.
I kind of like that, though.
It also, it's kind of an interesting format. It's called base 58. And there are no lowercase L's and there are no zeros. So you don't have the O0 problem and the 1L problem.
Oh, yeah. That happened when I was buying the computer systems from Neo on like 4 monitors, and the freaking pin numbers on the base of the Thunderbolt displays. You know, it's like flipping over 20 Thunderbolt displays, man. Jeez. I told Jonathan to help a brother out, or hire someone to do it.
Bitcoin received. Thank you, sir.
Thank you, sir.
So the deal is this. The thing that's big debate in Bitcoin right now is, you know, it's the one way of summarizing it is, should Bitcoin be coffee money? Like, and, you know, should you be able to buy a cup of coffee with Bitcoin in 20 years? And it's not a simple answer. So I think the technical people are right in believing that the single most valuable thing about Bitcoin is its completely decentralized nature. Nobody's in control of it. Everybody can verify it, run their own, you know, transaction verification, all of that shit, right? There's no central committee that decides jack shit about it. Like, only the people running the software make Bitcoin what it is. That means it's like, you know, politically immune, like no country owns it. No, it's independent of political concerns, independent of economic policy concerns, all of that shit. It's like, it is just Bitcoin. Yes?
Absolutely.
And the, you know, secondary benefits are, it's super scarce, which makes it like gold, but it's better than gold because it's cheap to store, easy to secure, easy to transmit, like you just did. Like, you know, gold's pretty cool, but you can't send it to me in 2 minutes over the internet, right? But a lot of people want more people using it, and the you know, i.e. they want it to be coffee money. And there is a limit on how many transactions can be made based on what's called the block size limit. So every 10 minutes, all the transactions are, you know, stamped into a block and become the permanent record of what went on in Bitcoin.
Right.
And right now, every 10 minutes, you can only have 1 megabyte worth of transactions. And over time, that's going to be, not enough. And I'm using kind of finger quotes because what it really means is that the transaction fees are going to rise. Like it's going to become expensive to make a Bitcoin transaction versus the current, couple of cents, which is extremely cheap in the financial world to make a transaction. It might end up being a couple of bucks 10 years from now.
Right.
Which is still cheap in the traditional world, given the special qualities that Bitcoin has. Like it costs a lot more for Brinks to come and take gold somewhere.
It's true. It's true.
And so here's the problem. The problem is if they make the block size big, it means, particularly if that's used as a general scaling solution, then the number of people who are going to be able to afford to run a whole node and who can effectively run a whole node worldwide on limited bandwidth. If you're in the middle of Tunisia and you want to be involved in Bitcoin, you don't have much bandwidth. 1 megabyte every 10 minutes could be a problem. 100 megabytes every 10 minutes is a much bigger problem, and a gigabyte every 10 minutes is going to be a real problem.
Right. Totally understand.
So the devs are like, hey, we need to keep the block size down so we can keep this thing distributed. Almost everybody agrees it will need to increase over time. The question is when, and we're getting up on full blocks. Like they're
Yes. Hello? I can.
Okay, cool. I'm just bringing up a window here. Bitcoin. Right. So, come on. Okay. So, there's. That's not what I want to see. Why is it showing that? I don't know what these. That's growth and fees. So many ways to look at this. All right. So the average size as of right now is 600K, 0.6 megabytes ish, right? But it's peaking at around 800. And in a given day, sometimes we'll see full blocks, certain times of day and that sort of thing. So people are like, shit, man, we're about to run out of transactions. Right?
Yeah, that makes sense.
And that could be bad for Bitcoin, right? And even some wallets, sometimes people send transactions and they take, an hour to get through, whereas they're used to them taking 10 minutes or sometimes even longer if the wallets are old and they don't set fees dynamically. Like the wallets are trying to catch up to this and figure out how much you need to pay to get in the next block and all this shit. Like there's a lot of activity going on. And I think it's kind of cool that at a relatively small size and an early date, they're letting all the wallets work out all the shit out. Because if it were in wider use in the public and it started becoming, apparently unreliable, it would be a bigger deal than when a relatively small number of users are using it, and all of who kind of have a deep understanding of it and appreciation for it. Right? It's like it's a very pro Bitcoin crowd right now. So, but there are really interesting scaling solutions, the likes of which are called like a Lightning Network, where well, it's a whole subject on its own, but it would allow, like, if you and I are swapping money all the time, like you've been sending me these on a regular basis.
Yeah, I would say that would be true.
Right. But I mean, even more like if you think about in terms of a web service or something, like say the subledger clients who send 1 million requests a month.
Right.
Like, how would they pay in Bitcoin on a per request basis? And there's some incredibly cool shit using Bitcoin's kind of programmable nature where we can set up we can set up some money that's locked between the two of us, where I can know that they have the money to pay. And then like when they send the first request, they send me a transaction that says, okay, Subledger, you can have a penny. They actually send me a signed Bitcoin transaction that I can submit to the network to get money. Okay. And what they do is they say, I've got, you know, $1,000 set aside for the month of January for Subledger. And that can be updated and everything. But the first transaction they send me says, okay, Subledger gets a penny and the rest goes back to the client. And they send me that transaction signed, ready to submit. If I sign it and submit it, I get my penny. Okay. But the thing is a penny's less than it costs to make a transaction on Bitcoin. So I'm not really interested in that. Right.
You're more so interested that you can actually, you know, play the game, not necessarily like how much that costs or the token costs or something.
Right. So then the next one, they send me a request that says, okay, well, here's 2 pennies and the rest goes back to me because they've made 2 requests now, right? Every time they make a request, they just allocate more of the funds to me. And at any time I can say, okay, hey, you know, I'm going to transact this. Let's start over. Right? It could be a month, a year, whatever. Right? So we can take a ton of transactions off of the actual blockchain and not bloat the blockchain dramatically, but do recurring transactions like that with a lot of different people. And it kind of is like the difference between a checking account and a savings account, where the blockchain will be your savings account, but you have these what are called payment channels open that can send and receive funds. And what's kind of cool is I can send transactions back as well. So check this out. So like volume discounts, they can say, okay, you get a penny, you get 2 pennies, you get 3 pennies, you get 4 pennies. And when they get up to like $100, I can say, hey, thanks, man. Thanks for sending me $100, which I haven't transacted yet. Here's a transaction where you send me 90. You send me 100 and I send you 10 back because you're a good customer. Like there's your volume discount.
That makes sense because anything that remove chips away at administrative costs, if you will.
Right. But it allows us to do these transactions, which are at any time, they're like good as gold, right? Like those are real Bitcoin transactions. And we know by the way that the original transactions were set up that the funds are there and are ready to be spent. Like you can't run into an overdraft situation.
Oh, well, there's no such thing.
Well, but yeah, what I'm saying is the transaction isn't a promise to pay.
Right. There's no such thing. I mean, in Bitcoin land, like that's really accounting at its essence, like double entry accounting at its essence, right?
Yeah. So it's very cool, but it's causing a lot of stress right now. I mean, people are, basically throwing handfuls of shit at the developers, saying, "Oh, they're trying to destroy Bitcoin," and blah 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 blah. And the people saying it, for the most part, aren't very technical, and they're just like, "Fuck, make it bigger." And the devs are kind of being, like I said, it's like both sides. It's like the Palestinians and the Jews or something. It's like, or Israelis, I should say. The it's like they just can't get together on this issue. And it's like, it's like, look, you're both right. Like, it needs to scale. Like, I don't think we should run out of space. That would suck. At the same time, we don't want to wreck the best thing about Bitcoin. Like the fact that it can be distributed, almost anybody can run a node. Like, that's a powerful thing.
So so what do you think? When do you think the coin flips?
There's a bunch of work being done on the payment channels thing that I've talked about. That'll take a lot of pressure off. Some old school wallet developers, though, have come out and said, yeah, I'm not going to implement that shit. Like, it's not Bitcoin, blah, 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 which I think is really short-sighted and ridiculous. But it probably just means other wallet vendors will just run over the top of them. Certainly the Bread Wallet guys made no such statement. I don't have a problem owning. I don't have a problem with the Bitcoin backbone being like a high volume settlement network or a low volume settlement network. That's ultra secure and beats the hell out of any settlement network on the planet today. If it gets to that point, then I think Bitcoin is quite valuable. And, I'm happy to have the ones that I have. But I hope there's a part of the concern. I also hope that the developers part of the reason developers don't want to expand the block size is because they want to create higher fee structures for the miners, because a very small part of miner income today is Bitcoin transaction fees. Most of it's the minting of new Bitcoin. Every block 25 Bitcoin are rewarded. That's way more than they make in fees.
Yep.
And but to me, that's a bit of kind of central committee planning bullshit. Like, we should let the market work that out, I think. Like, I don't think all the miners are going to walk away simultaneously and destroy Bitcoin. I think and they have mechanisms, like, they don't have to do anything. That's what people don't seem to understand about this. Like, they're used to, like, if the Bitcoin developers make a really bad choice and everybody in the community hates the choice, we can just run old software and it'll keep working the way it is. Or somebody else can come up and say, okay, we're going with a 2 megabyte block size. And if more than 50% of Bitcoin users agree, that's Bitcoin. It doesn't matter. Like, we can fork the code. It's in GitHub, and start running new nodes. And if everybody agrees, you're Bitcoin. Like, consensus is everything in Bitcoin.
Got it. So wait a minute there, Professor. You're saying that you can, whoa, I see. So you can actually create your own Bitcoin network?
Kind of. Like, what can happen is if you change the consensus rules, you get like a fork in the blockchain, and you'll have coin on both sides. Like, the rule is the longest valid chain is Bitcoin. And the question is what's valid and who agrees? Right? So say the original Bitcoin repo just locked at 1 megabyte, and somebody else came out with a 2 or a 4 megabyte version, and everybody's like, all the miners, or not all of them, but effectively 51% of them say, hey, I'm starting to run the new software because I think the core developers are way the fuck off. Right? Like, everything will keep running. And then when 51% of the people are using the new rules, the network as a whole will start rejecting the old 1 megabyte code. Or that's not quite what'll happen. What it'll do is it'll keep processing blocks that are bigger than 1 megabyte. And the original nodes won't accept those, right? They'll say, hey, this is an invalid block. But the thing is if 51% of the miners and the nodes agree that 2 megabytes is valid, then that becomes the longest chain, and that is by default Bitcoin. Okay, and what happens in that circumstance is you have coins on both sides, but if it's obvious it's going like one way or the other, what's going to happen is people are going to they're going to sell their coins on the losing chain and buy more coins on the winning chain. So like the price difference is going to be really dramatic, right? Like there's no value in coins on a defunct chain. And when the chain forks, you have coins on both sides.
I see. Okay, I totally get that.
So the value is gonna, like, it's gonna whipsaw really fast. Like when the handwriting's on the wall that it's going one way or the other, like everybody's gonna just instantly try to get rid of their coins on the losing side, get something for them, and put them on the other side because they're going to zero. Like as soon as you know, a substantial majority have decided on on whatever the longest chain is, the old chain's fucked. Now, if people want, they can continue to operate on that old chain, but they're going to be, you know, extremely limited in who they can work with. It's what's super unlikely is that you end up with two viable chains. That's incredibly unlikely. And even if that happened, and people who had coins before would just have coins on both sides. Like, so you can't lose anything.
So it's like getting in that nature.
Kind of. Yeah. But what it would do is cause a great deal of confusion, and no doubt in the press, people would be like, oh my God, it's falling apart and blah, blah, blah. It wouldn't be good. Like, I don't think it's the thing that, you know, it wouldn't be the optimal outcome. So I hope the sides can get together and, you know, and come out somewhere in the middle. And it seems to me like the technical people and the people who are going to make shit happen are closer to agreement than the vocal community is screaming about.
That all makes sense, and that's clear. But I do know one thing. I do know is that we both got some coin.
Yeah, I'm super happy you have some for yourself. I think it's really wise. And when it's, you know, you bought it at $450 or whatever, when it's worth 800, you're going to be damn happy you did. And when it's worth 80,000, you're going to be really happy you did.
Got it. Understandable, man. That's good stuff, and so I learned a ton. Thanks a lot, Tom. I appreciate you.
You bet. Good night.
Good night. Bye.